Yeah, good evening, guys.
Yes, sir. Good evening, sir.
Sir. Yes, sir. Good evening, sir.
Yeah,
Good evening, sir.
thank you. So let us start session. So let us start session. Yeah, last class. Yeah, last class started all these basics. Yes, so previous class about software. Yes, in software, basically two categories: system software, next application software. System software interacting with the hardware components. Example ways. Example ways. Next application software for the purpose of application development. These kind of application like WhatsApp, Facebook, like these different applications. To develop these kind of applications, application software. Yes. Here Java is application software. Java comes under application software. Java is application software. Next, about voice also discussed here. See, can we run any program without voice? No. Without voice, no program. We can't run any program here. If no voice, if no voice, no computer. If no voice, no computer. See, except bias to run all programs voice required. Except bias to run all programs voice required. So bias stands for basic input and output system. Yes, it's a hardware. It's a chip level program. So bias task is to boot voice. Responsibility is to boot voice. Booting, it's a process of loading voice from hard disk to RAM memory. Loading voice from hard disk to RAM memory. Voice is a platform where we can see voice hardware on top of voice, all programs running, right? So voice acting like a platform. It's a platform. Top of it all are it's a flat. Voice is a platform where we can run all the application software. So you get Java is a application software. Let us move to application software. In application software, there's a front end, back end. Front end, back end. See, this is web application architecture. Web application. Any application running on the internet. Any application running on the internet is a web application. In this, there is a front end, back end. Here, this is front end, back end. Okay. So this is front end. Next, here application comes, database comes here. Front end. Suppose, for example, here, for example, suppose registration form. Your registration data simply goes to application form that insert into database. Yes, the data simply goes to application. Application will insert data in database, right? So Java comes here. Java application type. So Java comes here, right? Java comes here. Java comes here, right? Java comes here. So Java is a server side working its backend. Backend. Java is a backend. Java is a backend software. It's a backend software. Java is a backend software, right? Backend software. Right. Next, in front end backend software, language and packages. Language and packages. In languages, low level, high level languages. Previous class we have discussed about low level, high level language. Low level language. System understandable language. It is in the form of binary code. Yes, it is called as machine language. Low level language called as machine language. Next, high level language, it's a user understandable language. It is like English language. It's like English language, very easy to understand. C, C++, Java, and all this comes under high level language. All the high level language. Okay. C program, Java program looks like English language. Yes, it's a high level language. Yes, it's like English. It's English. C program, Java program, Python, all are looks like a English. So these are a high level language. High level language, right? Yes, in high level language, first C is a first high level language. C is a first high level language developed by Dennis Ritchie. Developed by Dennis Ritchie in the year 1972. In the year 1972. Okay. So this is about high level language, low level language. Okay. So every high level language program has to convert into binary code. Otherwise, system cannot understand. Java program system known about Java program, C program, C++. That has to convert into binary code. For this, either interpreter or compiler. Okay, either interpreter or compiler. Okay. Yes, interpreter or compiler converts from high level language. Convert from high level language. Either interpreter or compiler. Either interpreter or compiler converts from high level language. High level, yes, high level language. High level language. High level language to binary codes. 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 Say either interpreter or compiler. Interpreter or compiler converts from high level language to binary code. High level language to binary codes. Yes. See, both are doing same thing here. Both are doing same job. Interpreter or compiler converting from high level language to binary codes. But some difference. Both are converting from high level language to binary codes. Binary codes, but some difference is there. Both are converting from high level language to binary code, but some difference is. What's the difference here? Let us see interpreter, compiler, the differences. First, let us say about interpreter. First about interpreter. Yes, interpreter. Let us see about interpreter. First of all, let us say about interpreter. Interpreter. Yes, for interpreter, I'm taking Python. Best example, Python. Python is a interpreter based. Python is the interpreter based. For example, test.py. For example, I'm taking Python script. Yes, to explain about interpreter, just I'm taking Python scripting. To explain about interpreter, taking Python scripting. Yes, let us see. Python scripting. Yes. Support test. Support test folder. In this, I'm writing simply Python script. I'm developing simple Python script using Notepad. Just I'm developing Python script using Notepad. Just I'm using simply Notepad. Yes. So detailed test folder. Detailed test folder. Yes. Now we should go to command prompt. Go to CMD. CMD. Open CMD. Command prompt. At the command prompt, now should go to D drive. D drive. D colon. That will take to D drive. D colon. That will take to D drive. In D drive, this is a test folder, right? D drive. In D drive, here this is a test folder. Test D drive test folder. Now dir. So output like this. See, all these are directories. 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 So you can test is a directory. Test it directly. So you can dir test is what it's a folder, right? Folder directory both are same. Folder directory both are same. Folder directory both are same. Okay. Yes, here D drive. All these are folders, right? Folders. It's a GUI. GUI. See, Windows is a GUI OS. GUI stands for graphical user interface. So graphical user interface. Windows, it's a GUI. Windows is a GUI. Windows. See, it's a Windows OS. D drive. Here all the folders, right? This is GA, right? Their folders. Yes, in GA calling as folder. GA calling as folder. As per GA, it's a folder. In GA, it's a folder. Folder. Next. See at the command prompt. So this command prompt, right? Yes, is a directory. See. Here in D drive here. In D drive, see all these names. MN Advanced Java, C language like framework, Hadoop, Java, Linux, Oracle. All of these things are folders. All of these things are folders here. Same thing here. These are directories. See, MN it's a D. DR means directory. Directory folder both are same. Directory folder both are same. No difference. Directory folder both are same. Both are same. Yes, in GA calling as folder, graphical user interface. GA. Okay, right. Next here, CA or CLI. So this is called as CA. This is CA. It's a CA, character user interface. CA. So CA means character user interface. CA, character. Yes, character user interface. Character user interface. CLI. This is command line interface. Command line interface. CA stands for character user interface. CLS stands for command line interface. Character user interface, command line interface. Okay, so this is command prompt. It's a CA. Yes, Windows. It's a GA. See D drive here. This is a test folder. Test folder. It's a folder. All their folders, right? They are folders. Folders. Same thing here. Directory. So in character interface, calling as the folder directory. Both are same here. So directory. Right? Directory. I think clear. So folder and directory. Yes, both are same. Folder and directory both are same. Both are same. No difference. Both are same. Both are same, right? Yes, in GA calling as folder. In GA it's a folder. Next in character user interface or CLI. Here calling as directory. Both are same. Only terminology difference. Both are same. Both are same. Both are same. Okay, fine. Now here. Yes, to explain about yes, today topic is interpreter. Today topic is about interpreter or comparison. Interpreter and compiler topic. Today topic is about interpreter and compiler. Today topic is about interpreter and compiler. Okay, interpreter and compiler. So first I'm explaining about interpreter. Just explaining about interpreter. Interpreter. For this I'm taking Python example. For interpreter, I'm taking Python. Python is the best example for the interpreter-based language. Python is a interpreter-based language. Python is a interpreter-based language. I'm taking Python for the interpreter example here. So for this, I'm writing simple Python script. Yes, I'm developing Python script. For this, I'm taking some test folder. Yes, D drive here. This is a test folder. Here, I'm writing some Python script. Python script. So for this command, using Notepad. Using Notepad, simply developing some Python script. Using Notepad, just developing. Yes. So for this here, so first CMD command prompt. Command prompt. It's a command prompt, right? Now, so now here I wanted to go to test folder. D drive test. Just I wanted to go to test folder for this. So D colon that will take to D drive. DR. Check it. DR content, all the directories. Here this is a test directory. Test folder, here it's a directory. So in D drive, test is a folder. It's a folder, same thing. Yes, in command line, it's a directory. It's a directory. Now we should go to test directory. So for the CD means change of directory. CD change of directory. CD test changed. Now we are in test directory. Yes, test folder. Something is there here. Yes, now test folder. Yes, dir, check it. Yes. 0 files, no files. Yes, here only 2 folders are there, but don't have any files. Okay, CLS to clear the screen. To clear the screen, dir. Now here writing, simply just writing in Python script here. Python script. Yes, I'm taking simple Python script. Notepad, test.py, notepad test.py, Python script. Do you want to create new file? Yes. Python script. A is equal to 10. Next, B equal to 20. C equal to A plus B. Yes, print that addition. Addition is equal to C. Displaying C value. Next, C equal to A minus B. Print subtraction. Subtraction is equal to C. Next, C equal to A into B. Very simple script here. Yes, addition, subtraction, multiplication of two numbers. Print multiplication. Multiplication equal to C. So A value 10 here. A equal to 10, B equal to 20, C equal to A plus B. Yes, print addition equal to C. C equal to A minus B. So displaying C value, C equal to A into B. Next multiplication. So this is very simple script here. Very simple script. Save, saved, save and close. Next, go to command prompt. dir. Here you can see test.py. Right? The test.py. Let us run it. Python test.py. See that. Got it right? Okay, CLS dir Python test.py. See that. Addition equal to 30. 10 plus 20, 30. Subtraction 10 minus 20, minus 10 here. Multiplication 10 into 20, it's a 200, right? 200. Okay. So what is happening here? Directly it's running. This program running directly. It is not checking for any errors. Not checking for any errors. Simply program is running. Program running, right? Directly running here. It's not checking for any errors. Suppose any errors, what happens here? Suppose here comma missing. Suppose here bracket missing. Suppose here double quotation missing. Something missing. By mistake, something missing, what happens here? Yes, so here first one mistake here. Next mistake, next mistake. There are errors. So there are 3 errors actually here. Here first mistake, second mistake, third mistake. There are 3 mistakes in this program. There are 3 mistakes. Now run it here. Python test.py. Run it here. See this. Giving a right. 7th line error. 7th line. Actually, there are 3 errors. Actually, there are 3 errors, but it's giving only 1 error. It's giving only 1 error. So what happens with the interpreter here? How interpreter working? Yes, let us see. Interpreter. How interpreter is working? How interpreter is working? Yes, your program statements. For example, A equal to 10, first statement. Next, B equal to 20, next statement. C equal to A plus B, next statement. Print that addition value. C equal to A minus B. Next, print subtraction. Next, C equal to A into B. Yes, print multiplication. Okay. So this is your Python script, right? Yes, let us say Python script is like this. Now, okay, interpreter, how this interpreter is working here? Interpreter checking first statement. If first statement is correct, then it goes to next statement, checking for next statement. Next statement also correct. Then checking next line. Suppose something wrong here, simply stops. Yes, something wrong. First line checking, if it is correct, next go to next line. Next line is correct, next go to next line. Something wrong, simply stops. It will not check remaining statements here. It will not check remaining statements. So line by line checking, first line checking, next line checking, something wrong here, stops. So interpreter shows only one error. So here interpreter shows only one error. Interpreter shows only one error. Okay. So any error comes, simply stops. Any error simply stops here. See here, same thing happened here. So seventh line error. So here it's error, right? Seventh line error. No corrected mistake. Seventh line. So this is seventh line. Here it's error, comma, mistake. Yes. After fixing this error, after fixing, yes, after fixing, now run it. Python test.py. Run it here. Yes. Now 13th line error. It's giving 13th line error. So here first seventh line error fixed here now 13th line, right? Means only one error at a time here. Yes, it shows only one error. Yes, only one error. So you can fixing this is yes fixed. So right? Yes, fixed. So here any error comes simply stops. Any error simply stops. ls now run. Yes, run it. Next line error. 15th line error now. Now it's a 15th line, right? It's a 15th line. Now let us correct this error. Yes, 15th line. So you can double quotation missing, right? Save and close. Yes, next. Now run it here. Yes, no. 1 second. Sorry, here. Yes, control yes, save. Control yes. Save. Now run it. Yes, no error, everything's fine. Here, this is working of interpreter. See, interpreter checks the statements line by line. First line checking, if it is correct, next line checking, if it is correct, next line. Suppose something wrong, stops. Something wrong, stops. Something wrong, stops. Suppose everything is fine. Suppose this is correct, this is correct, and this is correct, and this is correct. Top to bottom all are correct here. Next, what happens here? Top to bottom all statements are correct. Then execution starts. So first checking from top to bottom, any error comes, simply stops. Any error stops. Suppose no error, next line. No error, next line. Suppose here error, stops. Suppose no error, next line. No error, next line. Suppose no errors, everything is fine. Now interpreter converting, yes, this code to binary, source code to binary code. Now this converts into binary code, zeros funds format. Zeros funds for binary code. It's a binary code. That binary code given to processor. So binary code simply binary code given to processor. Binary code given to processor. Simply that binary code given to processor, right? Processor taking that binary code, executes generative output. Yes, if no errors. Now line by line conversion. First line conversion in binary format. See, this code is a source code. This is called a source. Your program is called a source. It's a source code. This program is a source code. Source code. This source code now converting into binary format line by line. First line converting and given to processor generating output. Next, second line. Second line converting. Now second line converting. Yes, 1 second. Second line converting into binary format. Like this line by line converting to binary format and again given to processor. So taking that binary code, generating outputs. Simply generating outputs. Next checking for next line. Next line also converting to binary format and generating output. Next line converting to binary format, generating output. Next line converting to binary format, generating outputs. Like this here. So here first initially checking line by line, any error simply stops. Any error simply stops. Suppose if no errors, then execution starts line by line. First line converting to binary format, generating output. Next line converting to binary format and given to processor generates output. So line by line checking and line by line execution. Line by line checking, line by line execution. This is interpreter. Any error comes, simply stops. Any error simply stops. Now let us say about compiler. Compiler, about compiler. See about compiler. How compiler is working? How compiler is working? For compiler, I'm taking C program. For compiler, just I'm taking C program. For compiler, taking C program. Suppose test.c. Test.c. For compiler, I'm taking C program. Yes, if it is C program, how this will be working here? Let us see. C program. For compiler, I'm taking C program. For compiler, simply I'm taking C program. Just I'm taking C program. Compiler. Yes, if it is compiler, how is working here? Compiler. Yes, best example C program. C is the best example for the compiler. Yes, compiler. Checking first statement. If first statement correct, then checking next statement. Next statement correct, then checking next statement. Suppose something wrong here. Compiler shows error at some line. Something wrong. Compiler shows error at some line. And then go to next line also. On next line, yes, even error comes, it goes to next line. If his interpreter stops. Yes, interpreter stops. If any error comes, interpreter stops. But compiler is not like that here. Compiler checks the whole code from top to bottom, checking whole code from top to bottom. Top to bottom. Okay, any error? Yes, error at some line. So next line checking. Next line checking. So next line checking. Suppose something wrong shows, right? So compiler checks whole code. Compiler checks whole code from top to bottom and shows all the errors. Compiler checks whole code from top to bottom and shows all the errors. Let me show the compiler example. C programming. Let us take C programming for the compiler here. C programming. Yes, C program. Here, this is C program. C program. C program main function. Main function. Yes, int ABC declared here. CLRS here. Enter first number. Reading first number, second number. C equal to A plus B. C equal to A minus B. A into B like this. Saved. Also compilation. Now simply compiling. Yes, success. No errors. Success. No errors. No run it. Yes. Enter first number 10. Enter second number 20, right? See this. Addition 30, subtraction minus 10, multiplication 200. Multiplication 200, right? Yes, here compilation, no error, success. Compilation success, no error, press any key. Now run it here. So when I try to run it here, yes. So enter first number 10, second number 20. So result addition, subtraction, multiplication completed. Successfully completed. Suppose something wrong in this program, what happens here? Something wrong. Something wrong. Suppose, for example, here semicolon missing. Suppose here bracket missing. Suppose here comma missing. Okay, comma missing. Suppose here semicolon missing. Okay, suppose here comma bracket missing. Suppose here double quotation missing. Right? Next here some bracket missing. Yes, what happens? Now save this modified program. Save it. Save yes. No. See yes. Save option here. New open save option. See yes. Overwrite yes. No compilation. See that. Yes, there are 8 errors totally. 8 errors. 8 errors. Press any key. Press any key. Press any key. Press any key. See the first error. Yes, look at the bottom here. 9th line error. See, look at the bottom. Look at the bottom. 9th line error. 11th line error. 16th line error. 20th line. And 22nd line. 28th line. 30th line. Yes, 34th line here. See, this, all the errors from top to bottom. Compiler checks the whole code from top to bottom, shows all the errors. Compiler checking all errors from top to bottom, it shows all the errors. It shows all the errors. Now let us correct the mistakes here. Here bracket missing. Yes, that mistakes. So you get this bracket missing, here bracket missing. Suppose here comma missing, and then yes, here double quotation missing, right? Now save it, yes, overwrite yes, no compilation. Yes, still 3 more errors, still 3 more. Yes, here, so here semicolon missing, next here semicolon missing, here also semicolon missing, and then yes, now save it, saved, yes, no compile. Here still one more error. Where is that? Here, this one. So you can scan up, bracket missing, now save it, saved, yes, so overwrite yes, no compile, success, right? Successfully completed. Now run it, 10, 20, yes, that's it. So what is happening with compiler here? What is happening with compiler? So with compiler, so compiler checks the whole program from top to bottom. Compiler checks whole code from top to bottom and shows all the errors. Interpreter is only one error. Interpreter is only one error, but compiles all the errors from top to bottom. Suppose if no error, everything is fine. Suppose if no error, everything is fine, then what happens? Let us see. If no error here, if no error, something happens. If no error, everything is fine. Everything is fine. Then compile opens another file, one more file. It opens one more file. Compile opens one more file. It opens one more. If no errors, if everything is fine here, compiler it creates another file. It opens another file. After opening another file, this whole code, that source code, that C program, this is source code. This source code simply converting to binary format. This source code simply converting to binary format, right to this one here. This whole code converts into binary format, zeros, ones format here. So complete code converts into binary format like this. Complete code converting into binary format. Complete code converting into binary format like this. Okay. All this code convert into binary format. Zeros, ones, binary format, right? Binary format, right to another file here. So compiler checks the whole code. Compiler checks whole code from top to bottom. Compiler checks whole code from top to bottom. If no errors, then it generates one exe file. Test.exe file. Yes, compiler checks the whole code from top to bottom. If no errors, generating that exe file. Yes, that exe file given to processor. So processor taking that exe file, then generating output, simply generating output. This is working of compiler. Yes, let me show this exe file. Yes, exe file for C program. Yes, so this is your C program. Yes, behind of C program. Yes, that exe file generates. Exe file. Saved, okay. Yes, behind of C program. C drive. TC means turbo C here installed here. Yes, it's a pin folder. Inside the pin folder, here's a test. See, test.cpp. So CPP and C both are same. CPP is C++. C++ compiler using for the C language also. For C language, we are using same compiler. Say this is your C program, right? It's your C program. So this is your C program. So backend test.cpp 73 today just to modified it. Date and time of date modified today. Okay. Now the related programs. Let me delete all the related programs. Test. So this is your test.cpp. Right? So this program just I'm compiling. Compile success. Suppose if no errors, what happens here? Yes, if no errors, it will generate Yes, if no errors, it will generate some exe file then running. Run it here. See, look at the bottom here, test.exe file generated. Just now test.exe file generated. Just now test.exe file generated. Yes, refresh. See that test. So it's a test.cpp. Next here test.exe file just now generated. Properties you can see test.exe file. Application .exe file generated. .exe file generated and executed. Yeah, this is exactly difference between interpreter and compiler. Okay. Yes, in case of interpreter, what happens here? Checking program from top to bottom. Yes, first line, next line by line checking. Suppose any error stops. Any error stops. Suppose if no errors from top to bottom, everything is fine. Then first line converting to binary format, then executing. Second line converting to binary format, then executing. So line by line checking and line by line execution. Line by line checking, line by line execution. Okay. So interpreter checks the program line by line and also executes program line by line. Yes, if it is compiler, what happens here? Compiler checks the whole code from top to bottom. Compiler checks whole code. Compiler checks whole code from top to bottom. It shows all the errors. Compiler shows all the errors. Interpreter is only one error. But compiler shows all errors from top to bottom. Suppose if no errors, simply this code converting to binary format. This code converting to binary format and write to one exe file, generating one exe file. After that executes. Right? So this is difference between interpreter and compiler. So this is difference between yes. So this is difference between interpreter and compiler. Tell me guys now what do you observed? Difference, exactly difference. Interpreter and compiler differences. Tell me guys, anyone? See, this page explained about interpreter. This page explained about compiler. So between these two pages, what's the difference exactly observed here? Anyone? Any difference observed here? What do you observe? No one?
Actually, while executing the code, interpreter checks for line by line. On the
Okay.
when the error occurs, it stops on that exact line.
Yeah, okay, fine, good.
While
Compiler.
compiler no what compiler note down its errors entirely in that program, and finally it gives the like a result in the sense of what are all the errors, how much
Yeah,
errors are there.
fine, good. Any other errors? Sorry, any other difference? Any other difference observed? In this page, what's the difference you observed? Next, one more difference observed here. One more difference. Here, what is this? It's a test dot
Exe file. Okay.
exe file. Here, exe file available. Interpreter, no exe. So this is exactly difference. So main difference between interpreter and compiler is exe file. Interpreter and compiler main difference is exe file. Yeah, let me compare these two. Interpreter versus compiler, that comparison. Let me explain all the differences very clearly. I'll explain points wise what's happening. Yes, let me explain points wise. Yes, interpreter versus compiler. The differences. Yes, I'll explain very clearly. Yes, interpreter versus compiler. Interpreter versus compiler. So first difference. Interpreter checks the code line by line. Yes, interpreter checks the code line by line. Compiler, it checks whole code from top to bottom. See, interpreter, it checks the code line by line. It checks the code line by line. Yes, interpreter, it checks the code line by line. Yes, compiler, it checks the whole code from top to bottom, checks whole code from top to bottom. Next, interpreter, if any error comes, yes, it stops. If any error comes, it stops. If any error comes, it stops. Right? So hence it shows only one error. Hence it shows only one error, only one error, right? Yes, interpreter. If any error comes, it stops. Hence it shows only one error. Compiler. Sorry guys, some internet issue. No, can you hear me now? Hello.
Yes, sir.
Yes, sir.
Yeah. Let us continue. Yeah. So interpreter, it checks the code line by line. It checks the code line by line. Compiler, it checks whole code from top to bottom. Next here, interpreter, if any error, yes, it shows all the errors from top to bottom. It shows all the errors from top to bottom, from top to bottom, from top to bottom, from top to bottom, from top to bottom. Right? So interpreter, yes, if any error comes, stops here. But compiler shows all these, it won't stop here. It checks all the errors from top to bottom. It checks whole program. It checks whole program from top to bottom. So it shows all the errors. All the errors, right? Yes. Next here, next difference here. Interpreter, it executes program line by line. Yes, it executes program. Yes, line by line. Line by line. It executes line by line. First line converting, then executing. Next line converting, then executing. Next line converting, executing. Right? In case of compiler, what happens here? Whole program converts into binary format, generating one exe file. Whole program converting into binary format, writing to some exe file. Right? It executes exe file at a time. It executes. Yes, it executes at a time. Since exe file generating, it executes at a time. Yes, it executes at a time. Okay, right? Interpreter, it executes program line by line, but compiler, yes, generating exe file and execute at a time. It executes at a time. It executes whole program at a time. Whole program at a time. Right? Next here, main difference here, interpreter, it does not generate exe file. It does not generate exe file. It does not generate exe file. Interpreter, it does not generate exe file. Compiler, it generates exe file. It generates exe file. So this is main difference. Exe file is a main difference here. Interpreter, compiler, main difference, exe file. Interpreter, it does not generate exe file, but compiler generates exe file. Okay, right? Yes, in case of compiler based program, first exe file executes, but interpreter source code executes. See, Here Python scripting. Here what is happening here? Only source code available, right? Here don't have exe file. Only that source code is available. Source code is available. So directly source code executes here. That source code executing directly. Yes, interpreter. It executes source code directly. It executes source code directly. See, it executes. See, it executes source code directly. It executes source code directly. Okay, interpreter. It executes source code directly. Yes, interpreter. It executes source code directly. Yes, if it is compiler, what happens here? It executes exe, it generates exe file and executes here. It executes exe file. It executes exe file. Right? So this is main difference. Fourth point, fifth point, main difference here. These 2 points are very, very important here. So interpreter. Yes, it does not generate exe file. Compiler generates exe file. So interpreter, it executes source code directly. Compiler, it executes exe file. Exe file, right? Yes, next difference. Next difference here. See, interpreter-based languages are called as scripting languages. See, these are called as scripting. They're called as scripting languages. They're called as scripting languages. Scripting language. Interpreter-based. These are called as scripting language. Compiler-based. Yes, these are called as programming language. Programming. Okay, programming language. So all interpreter-based are scripting language. Interpreter-based is a scripting language. Compiler-based is a programming language. Scripting language examples. Scripting language examples. Python is a scripting language. Python is a scripting language. Next, HTML is a scripting language. Okay, next, JavaScript is a scripting language. Yes, see, HTML. It's a browser understandable language. See, if it is Python, Python has its own interpreter. Python has its own interpreter. HTML for HTML browser. Browser is an interpreter for the HTML. Even JavaScript also is browser, right? See, HTML and JavaScript both are executed in the browser environment. So this browser, right? So this is your browser. It's a browser, right? Okay. Yes, it's a browser. Yes, it's a Google Chrome, right? It's a browser. It's a browser. In this environment, that HTML executes here. HTML and JavaScript executing by the browser environment. So browser is an interpreter. Browser is an interpreter for the HTML and JavaScript. Okay. So HTML JavaScript is a browser interpreter for this, right? Next, apart from this, yes, like PHP scripting, next Perl scripting, and next, yes, Linux shell scripting. Linux shell scripting. So they are scripting language. Yes. Programming language examples. C and C++, right? Compiler best example, C and C++. Next, .NET C#. So these are, yes. So programming language compiler based, these are interpreter based. So all these are interpreter based examples here. Interpreter based examples, these are compiler based examples. So finally here, so let us come to conclusion here. Interpreter based language don't have exe file. See, interpreter based language don't have exe file. Don't have exe file. Yes, compiler based. So everything generates exe. Everything finally converts in exe file. Converts into, yes, everything finally converts into exe file. Exe file and executes, right? Executes. So this is difference here. So main difference between interpreter compiler. Compiler generating one exe file. See here, test.exe file generated, test.exe file generated, test.exe file. In case of Python, no exe, directly program executed. So this is main difference. Interpreter does not generate exe file, compiler generates exe file. That exe file is a difference. Exe file is a difference. Okay, right? Fine. Now, okay, fine. Here's some doubt here. See, I'm explaining about all of the many things I'm explaining, right? Like Python, HTML, there are many things, interpreter, compiler, so many things explained. But Where is Java? Yes, now Java. Yes, Java, is it interpreter based or compiler based? Still not discussed it. Java still not discussed it, right? Is it compiler based? Is it compiler or interpreter? Java, yes, interpreter, compiler. Yes, let us. Let us start. Now I am starting Java. So after the software basics cleared. So previous class, in this class, all software basics completed. Now I am starting Java. Yes, today now I am starting. I am introducing Java. So what is Java? Yes, is it interpreter based or compiler based? Anyone idea about it? Is it interpreter based or compiler based? What is Java? Yes, Srinivas saying that interpreter. Java is interpreter based. Next, any others? Anyone idea? So what is Java? Yes, interpreter based, compiler based. Interpreter based, compiler based. So let me explain. Yes, Ajay is saying that compiler based. Hari Prakash saying that compiler. Yes, any other answers? Okay, fine. Let me explain. Just you decide. I will explain about Java. I will explain about Java. You decide. Is it compiler based or interpreter based? Just you decide it here. Yes. See, except Java, in other languages like C language, C++, or Python script, any other language, maybe interpreter based or compiler based. Interpreter based or compile any other case, except Java. Except Java in other languages. Except Java in other languages, what happens here? So first of all, source code. First of all, source code converts into, first of all, yes. So first of all, source code converts into binary format. Binary format. Source code convert into binary format. Binary code. Source code converts to binary code. That binary code given to processor. Binary code given to processor. So processor taking that binary code, generating output simple. Okay. Except Java. Except Java in other languages, source code converting into binary code, that binary code given to processor, generating output. Yes, now. So source code to binary codes, maybe compiler, maybe interpreter. Either compiler or interpreter. Some languages, compiler, some languages, interpreter. Okay, either a compiler or interpreter. Either a compiler or interpreter converting from source code to bytecode. Then executing. Yes, if it is Java, what happens? Let us see Java. Yes, in Java, what happens here? First of all, source code in Java, source code simply converts into bytecode. This is a bytecode. Java, this is a bytecode. That bytecode converts into binary code. Binary code. So there are two stages in Java. There are two stages. Binary code will be given to processor. Simply processor generating output, right? Okay. Yes. So other language source code directly converts into binary code. Source code to binary code. Only one step. Only one step. Source code directly converting into binary code. Yes, if it is Java, source code converts into bytecode. That bytecode converting into binary code. There are two stages here. In Java, two stages. Other cases only one step. Only one step here. But Java, two steps. Two steps. First, source code converts into bytecode. Next, bytecode to binary code. In Java, this is intermediate code. Bytecode. This is intermediate code. Yes, in Java, this is a bytecode, intermediate code here. So why bytecode introduced in Java? Why bytecode introduced here? So bytecode was introduced. Yes, introduced to make Java as an independent of platform. Independent of platform. To make Java as independent of platform. See, bytecode was introduced. Bytecode was introduced to make the Java as independent of platform. So main purpose of bytecode is to make Java as independent of platform. Yes. How Java made us independent of platform? Next we'll discuss. Wait for some time. Next I will explain. Now the source code to bytecode. First part. Source code to bytecode. This part by the Java compiler. This part by the Java compiler. Next, bytecode to binary code. Bytecode to binary code. This part by the Java interpreter. This part by the Java interpreter. Let me show the practically. I'll show that here. Java interpreter. Java interpreter. Okay. So first step, source code to bytecode by the Java compiler. Bytecode to binary code by the Java interpreter. So it's happening 2 stages. So compiler as well as interpreter both are involving. Both are involving. Yes, let me show that practically. Let us see that. Suppose same folder I am taking a D drive, test folder. Yes, now let us take simple Java program. Simple Java program. Yes, CLS, DER. Yes, simple Java program taking here. Notepad. Notepad, test.java. Notepad, test.java. Notepad, test.java. Notepad, test.java. See that. Notepad open here. Do you want to create new file? Yes. Okay. Yes. Not test.java. Public class test. Public class test. Simple Java program. Actually, for the Java program, Eclipse we should use. In Java programming, I'll be using Eclipse. Going forward, I'll be using Eclipse every day. Eclipse IDE. But it's very simple program. Very simple program. Just I'm explaining through the Notepad. Notepad. Simple program, just I'm using Notepad. Going forward, we'll be using Eclipse. Java completely development in Eclipse. Yes. So public static void. Yes, public. Yes, see public static void. Main string square bracket args. Main method starting, ending. Yes, here system dot, yes, out dot println. System dot out dot println. Here it's a hello world. Very simple program. Hello world program. Hello world. Just hello world. Okay, save it. Control yes, saved. Saved and closed. See, here, see that. So test.java is a source code. This is source. See that. This program is called a source code. It's a source. It's a source code. Test.java is source code, right? Now source code, just I'm compiling. Java sim is Java compiler. Java sim is Java compiler. Java C test.java. Java C test.java. See, program compiled. Program compiled after dot class was created here. Test dot class. Previously don't have dot class, right? Previously don't have dot class. No dot class was generated. Dot class was generated. Dot class generated. So what is happening here in Java here? So first, your test.java file. Test.java is a source code. So this is source code. Yes, it's a source code, right? Test.java is a source code. This source code given to Java is Java compiler. Test.java, it's a source code that will be given to Java compiler. Now Java compiler compilation, if no errors, if no errors, generating test.class file. Test.class file is a byte. This is bytecode. It's a bytecode. Okay. So test.java is a source code taken by the compiler. If no errors, generating dot class file. So this is called as bytecode. It's a bytecode, right? Bytecode. After that, now bytecode is ready. Okay, bytecode is ready. Source to bytecode. That bytecode is ready. Dot class file is bytecode file. No Java test. I'm running this bytecode file. Yes. Right? Hello world, got it right? So Java means this is interpreter. Okay, Java sim is compiler. Simply Java means this is interpreter. Now task is by the interpreter. Program execution by the interpreter. Program execution by the interpreter. So this dot class file taken by the interpreter. So dot class file. The dot class file given to Java interpreter. Now interpreter, Java interpreter, Java interpreter. So Java interpreter, that interpreter converting bytecode to binary code. That converting into binary code. Simply converting into binary code. Converting to binary code. That binary code given to yes processor. So processor taking that code, simply generating output. So what is happening Java here is like this. So first source code to bytecode by the Java compiler. Next bytecode to binary code by the Java interpreter. Okay. So source code to bytecode by the Java compiler. Bytecode to binary code by the Java interpreter. So what is happening here? Yes, in Java, see errors. Errors checking by the compiler, errors checking by the compiler, errors checking by the compiler. Suppose if no errors, if no errors, then generates, generates a dot class file, generates a dot class file. Now this dot class file, executing, this dot class file, the dot class file executing by the executing by the interpreter. Simply interpret, right? That's it. Interpret, right? So errors checking by the compiler, program execution by the interpreter. Means now tell me, Java, is it interpreter based or compiler based or both? Tell me guys, Java interpreter based or compiler based or both? Now what you understand from this? It's a both, right? Good. It's a both. So both is yes, in case of Java, compiler as well as both are involving. So first the compiler involving and next interpreter involving. It depends on both. So Java depends on both. Java depends on both the compiler as well as interpreter interpreter. Right? Java depending on both the compiler as well as interpreter. Java depends on both the compiler as well as interpreter. That's it. So this is Java introduction. Okay, Java depending on both the compiler as well as interpreter. Now finally, some question for you guys. Some question. Can we create exe file in Java? This is the question. Yes, anyone, can you answer this? What you understand? Can we create, have we observed any exe file in this process here? See, Java programming steps. So first step is Notepad, test.java. Using Notepad, writing that all code, complete codes, writing codes using Notepad, After that, next part, compilation, Java C test.java, compilation, right? Compiled. Yes, next, Java test, Java run it, Java test, right? Yes, high level, right? See this here only .java file, .class, right? Yes, no exe file. In this process, no exe file, right? Means no exe file concept in Java. Can we create exe file in Java? Means no. Answer is no. No. Java don't have exe file. Java don't have exe file concept. So reason here, yes, exe file concept eliminated to make this Java is independent platform. See, wherever exe file is there, that is platform dependent. Platform dependent exe file. Suppose C program C++ is exe based. C++ Java is exe based. Okay. C++ .NET. These two things exe based. So wherever exe based is, that is platform dependent. Yes, that exe file. Yes, exe file concept was eliminated. Yes, eliminated to make Java as an independent platform. Independent platform. Okay. So Java don't have exe file, completely eliminated. Reason to make it as independent platform. To make it as independent platform. See, in Java, everything is a dot class file. See, in Java, everything is a is a dot class file. But here dot class is not exe, different here. See dot class file, dot class file, dot class file, yes, is not an exe file. Dot class is not an exe file. Different, they're different here. So dot class file is not an exe file. See exe file is a binary code file. See exe file is a binary code file. It's a binary code. Exe file is a binary code file. Exe file is a binary code file. Yes, and it is a system, and it is a system understandable language. It's a system understandable. System understandable. System is processor. Processor understandable language. It's a system understandable language. See dot class. See dot class file is a byte code file. Dot class is a byte code file. It's a byte code file. It's a byte code file, and it is a JVM understandable language. JVM understandable. JVM understandable. JVM understandable language. Next, one more thing here. exe file is a platform dependent. Exe file is a platform dependent. Platform dependent. Platform dependent. So exe file is a platform dependent. Exe file is a platform dependent. Yes. But yes, whereas yes, dot class file is an independent of platform. Dot class file is an independent of platform. Independent of platform. Yes. Yes. How Java made us independent of platform, we'll discuss next. So next coming classes topic here. Yes. exe file dot class file defenses. So why exe file is dependent, platform dependent? Why dot class file independent of platform? Yes, platform dependent, independent of platform. The topics next session I will explain. In the next session I will explain. So this is Java introduction. Java started. So Java depends on interpreter as well as compiler. Java depends on interpreter as well as compiler. I hope it's clear, right? Yes, I hope everyone you understand here. So today's class, difference between compiler, interpreter, compiler and interpreter, compiler, interpreter. See that the differences. These are all the different. That all the differences. Yes, here it's prepared in document. Next about Java. Java depends on both compiler as well as interpreter. Same thing explained here. Source code to byte code to binary code, and then finally output. Right? Source code to byte code by Java compiler, byte code to binary code by Java interpreter. Same thing explained very clearly here. Okay, right? So can we create exe file in Java? No, no concept of exe file. Same thing explained clearly. So that's all about yes, Java introduction. Next session. Tomorrow going for Java installations. So tomorrow topic Java installation, JDK installation, Eclipse, and then first program we are going to discuss. Yes, after this basics completed, software basics completed. See all that basics completed. Software basics like system software, application software. Next about OS discussed, and next about front end, back end discussed. Java is a backend software, right? Discussed. Next about low level language, high level language discussed. Okay, and then yes, about interpreter, compiler discussed. Next, Java depends on both. So these things, so these basics, software basics completed. Software basics all complete here. Now we are going for Java. Tomorrow topic is Java installation. Yes, any doubts, guys? Tomorrow going for Java installation. Tomorrow starting Java installation. Any doubts? Any doubts, guys? Yes, any doubts? Yeah, 1 second. 1 second, guys.